In this particular video, I'm going to look into datetime objects from various packages, native Python, Numpy, and Pandas. So we encounter in many places. So there is a little bit of confusion in how to use it, what to use it. So I'm putting all of these in one place. Um, Primarily, if you are doing data science or machine learning, you will encounter this date time object in time series analysis, and also for doing feature engineering. If you have some date fields within your data sets, you would probably want to convert into what day of the week it is, what week of the year it is, whether it's a weekend or weekday, which quarter it falls, and so on. So it helps understanding easily compute those additional features, and also in time series analysis we need to do quite a bit of manipulation of the data. So it's better to understand what options we have in native Python, NumPy, and Pandas. So as far as Python native language is concerned, datetime is the class to look into, and within the datetime there is a date class. There's a time class which is hour, minute, and seconds, and date is year, month, and day. And date time is both date as well as time, until including time zone and so on. Delta is more about the difference. You can add some days to a date field and you get a new date with days move forward, and then the timestamp, which is number of I think it's seconds computed from January 1st 1970, or 70 or 71. I will go through it when in the few cells later. I have a detail of this one, and then there's strip time where you want to take some date and convert into some kind of a format, and you can take any of these date time and use this particular method and convert. And NumPy has a datetime 64 because datetime is already taken. They use datetime 64 to do it, and time delta is an equivalent of delta here, and date range is also another field. Pandas also has this timestamp, and then there is a datetime index, which can be used as index, so that for stock market, for example, every daily opens, highs, lows, and volume and so on. You can index by the date, so you can convert something into date using this date time, and also date range if you want to create your own data set, or mostly for that reason, similar to like a number range, you can have a date range. Series dot data accessor. Let's say you have a string series, you can use .dt. It's an accessor, and once you do this .dt, you can do a lot of operations like get the month or get day and so on. And then in reading CSV, you can also do like parse date is equal to true. It automatically try to detect which of the fields are dates and try to convert them. Right. So those are all the things that we are going to go through more or less very quickly. I won't run everything, but I think it's easy. At least I'm making these notes for myself, so that when I come back and look at it, I know what is there, so I can just go to that place and pause it and look at the code and use it in my day-to-day use. For example, if you want to know any particular package and want to know what are the methods and the attributes are available, you can simply call this dir datetime, right? So you import it and you're calling it, and it shows here date time is there, time is there, time delta is there. Actually, this was supposed to be time delta, and then time zone and these. So these are all available already. So this is what we are going to look in particular. So first, let's look at datetime.date. So you have to give this in this way, which is year, month, and date, and that creates a date. And once you have that, you can get a lot of you can retrieve year, month, and date with this object. And and if you want to look at all the functions that you have, like you have month, you have you can convert into a different format. You can get today's date, for example. You can get whether it's a weekday, what year it is. So you can get from this date object. Similarly, in time, if you print dir datetime.date, you see all of these functions. You get microseconds as well. So it is actually doing very precise storage of time up to microseconds, not just seconds but microseconds. So you can see, yeah, you can get hour, minute, and second. To create the object, you give hour, second, and object. So you can see 13th hour, minute, and 1 second. So another one is date time, where you combine both date and time. So in this case, I am just taking 2020 January 1st, and you can see it is 2020 January 1st, but you're also adding the time like 00. So this time minutes, hours, minutes, and seconds, and you can also get, for example, here I'm printing datetime dot now, and it is printing the date as well as the minute, second, but also it is also printing in microseconds. So it's very precise, right? So these are all, this is how it prints the current time, and these are additional functions where you can get minutes, seconds, you can get a timestamp, and so on. So strip time and delta. So this is a convenient function that can be used. So you can, for example, here I'm using strip time, and I'm saying you take this my date string, and you're saying this is how I'm providing the input. So now if you print my date, it will convert it to a date object. Once you have the date object, you can get whatever you want. But let's we are also doing this time delta. So for days, 100 days is equal to, you are saying you are creating this time delta object. This time delta object can be added to date object. So I added here my date to days 100, and you can see this is quite convenient. For example, if my date is 22nd May, and if I want to know what would be the date after 100 days, and you can easily get it to this way of adding time delta, and you can see here. So you see these are the directives for printing date in various format. Like let's say maybe you just have the last two digits. You can find a corresponding directive and use it here. Also, this is useful to print in certain format. You can take date time and print into certain format. Then also this can be useful. So yeah, you can go through this when needed, like hours in 24-hour format, I is in 12-hour format, and /p prints whether it's AM or PM, and so on. Now let's look at Numpy date 64, time 64. Very straightforward. You can create a similar. The format has to be in this way. So default is all years, month, and date. Other formats I notice that it doesn't accept, like if you use slash and so on. So but if you skip for example the days, it will automatically read it as a date as well. But if there is an error, for example, if the date is missing, then you can use NAT, not a time, date time object. So it will store missing value as this way. Okay, so what else? Yeah, so date range is another. So NP arrange. So if you say this is my starting date and this is my ending date. So when you create this one, it will create a range of values. So in this case, it created a range here. And also I think if you want to do add certain days, for example in 2009 January 1st, and I just write 2009, and I can add time delta 20 days, and this is the date that you get, right? So and also 2010 minus 2009, you get 1 year. You're expressing in terms of year, but because I'm providing input in years, it is printing in years. But if I provide input in days, it will provide in days. So Numpy is fairly straightforward. There are a couple of ways of creating these objects, but Pandas actually is quite useful, and timestamp is actually very useful because it can convert various formats into proper times even without us specifying what input we are giving. For example, I can give the input as March 4th 2020, or by slashes, or by comma separated by space. This is important. You can see that the output this one generates is exactly similar as the top two, but the output this one generates is wrong. So um, be careful and make sure that you give a space here to generate proper timestamp. Um, so another one, this one 04 is actually we are providing as uh, like a string, right? So instead you have to give a proper literal like 4. This will actually provide a proper time. This one will fail because 04 is not accepted. And you can also provide date time, and also you can provide like PM as well. So it will create a proper timestamp object from Pandas timestamp object. Once you get a timestamp, you can convert into any other format quickly and easily. For example, here I'm printing day, I'm printing day, name, month, and so on. So it's saying day is 4th, and then Wednesday, month is 3rd, and which is March, and hour is 0. So there are many other like you can get today's date, whether it's a week or weekday, week of the year, and so on. There are several functions, what quarter it is. Um, you can even get nanosecond, a minute, month, and so on. So these are all functions available within Pandas data frame, and we can use. But first, we need to convert it to timestamp, and then we can use all of these functions. Very convenient one. The second most important one, especially useful for time series, is to know time date and date time index. So it's fairly easy. You give date objects, and then you use this object as Pandas datetime index, and some dates it will convert into date indices, and those date indices are now datetime index, right? So you can see 100, 200, 300, and I'm just creating a data series with this as the index, dates as index. So now you have a series with these as the index. Another important function is to do date time. So for example, if you read an array, this is a string array, right? Some data string array. If you say to date some dates, so it will convert into a series of date time indices automatically, right? And also if let's say you give some date here which is not recognizable because it doesn't have year or month or some random alphabet, if you try to read this will throw an error here. So what you need to do is you have to do errors as scores. And then date range is another important functions in Pandas, and you can clearly see like any range you have to give start, end, and there is, if by default if you don't give any other fields, it will take frequency as the, as you can see here, frequency is D, and this is a Numpy array. So and then here I gave start is equal to end is equal to, and frequency I'm saying hour. So it's only one day, so there are 24 hours in one day, so it's printing all of the 24 objects here, and frequency is hour. You can also give like 6 hours as the frequency. In this case I give 6 hours, and so it's printed one timestamp from every 6 hours. So that's what you have here. So it's very convenient to generate a series. Frequency option, there are many of them, and you can use hours, days, years, and so on. So let me see if there are any available frequencies. Yeah, so these are all the frequency attributes. You have quarter, you have year, and frequency. You have hourly frequency, second frequency, nanosecond frequency as well. Yeah, weekly frequency, calendar day frequency, and so on. So these are some of the frequency options that you could use in here. So you can check out this link. Range with a period option. So it is, if it's not easy to always know what is the start date and end date. Let's say I just want to compute some values for the next 100 days, like stock price for next 100 days. instead of me trying to figure out what is the uh, end period, all I can do is like give today's date and then say period is equal to 100, or in this case I'm doing 10, and frequency is equal to day. So it will calculate what will be the date after 10 days, and it will create a date range. So you can see that it is creating, it's a convenient way of using periods to generate multiple dates. Similarly, you can give end date and then go back. So in this case, end date is this, so this is the end. Go back 10 days and create one. So that is what it did, which is also very convenient option. So another one is date.dt accessor. So it's, if you have a date time index, you can do all those operations such as figuring out what day it is, what month is, what quarter it is, and what hour it is, what year it is, and so on. But if you have a string, then to convert string to date, you have to use this accessor. For example, here I have dates. So for this date object, which is a series, series of 5. So 1, 2, 3, 4, 5, right? So but I am printing as a dot day. But if I create a series, if I say s1 dot day, it will fail because it thinks it's like a string, so it doesn't know what that dot day means. Series doesn't have dot day. So to get the functionalities of the date, you have to use this accessor dot dt. Then you can use dot date, dot week, dot month. So this is very useful to in generating new features. So for feature engineering, for example, this functionality can be quite useful. So let's look at one concrete example. In Pandas, you can install this Pandas data reader, and from that you can get a stock option. So stock values. For example, I'm getting Microsoft, this ticker symbol for Microsoft MSFT, and I'm giving a start and end. Almost a year data from September 10 to of 2021 to September 10, 2022. I'm getting all of those records, about 1 year worth of records, and you can see all of those values, when did it open, what is the low, what is the high for that day, and so on. Right, and then you have, if you want to insert additional field for weekday, for example, whether it's what day it is or what day of the week it is, so you can insert easily by doing this particular function call. Quite easy, right? So this is how you can do feature engineering, display, and you're adding additional variables. For plotting, you need to select the variable that you want to plot, and I'm selecting here open, high, and low, and plotting. You can see the plot figure. But if you want to add additional feature, for example, say plot figure size, if you want to expand it a little bit and maybe reduce the date, the duration, here I'm looking at a 1 quarter, I'm printing it. So this is easy to look at. And then we have one thing that I wanted to say is that we read a lot of files. So there are two ways of converting the fields when you're reading itself to datetime, is to use already defined data types of that file. The first column is datetime, second column is datetime, third column is string, and fourth column is float. For example, you can say d types is equal to t types. It's if you define it ahead of time, if you have like millions of rows, it is quite convenient and it's faster. The other option is to use this pass date is equal to true, where you don't have to specify which columns are dates. So Pandas will try to figure out which columns are dates. So just I want to recap before ending it. So we looked at date time options in Python, Numpy, and Pandas. In particular, in Python, the basics are datetime date, time datetime, and time delta. This is an error here, and then timestamp and strip time to print it in different format that we want. And then you have Numpy datetime, couple of options available. In Pandas datetime, very useful, and you can convert various formats of string dates into timestamp, and once you have timestamp, you can use many function calls on the timestamp. You can create a datetime index, especially useful in time series analysis and date range, and also we looked at how to read, and this is useful when we are dealing with time series analysis.